and do a creating model. And what we're going to do, we're going to be using inverse distance weighted interpolation. So it's a specific type of creating model. So I'm going to use the me-use grid. I specify what the coordinates are. So here I'm saying, hey, the coordinates are X and Y. I'm saying that, yes, this is gridded. So we're on an actual grid. And I'm going to specify that the projection is this one in particular. Now here what I'm doing the same thing, but now I'm using the me-use data set from the SP package. So previous we're working with the grid, now I'm working with me-use. Specifying the coordinates like I did before. Now I'm making sure that the projections match up. Now let's actually get our inverse distance weighting function. So what's happening is I'm doing an inverse distance weight model. I'm saying the log of the zinc measurement depends on a constant. So here I'm saying that there are no covariants. There's only the Gaussian density aspect going on. So there's no other covariance influencing what's happening. It's data points and Gaussian curves. So I'm not saying it's actually even. I'm saying the concentration corresponds to a Gaussian distribution. Here are the locations. Here is the data that I want to make the predictions on. So here I'm taking this data set for the zinc and I'm saying, hey, fit a model based off of this. Now make a prediction based off of these grid points so I can have the entire map mapped out. And now I want to save it. So here's a summary of it. And I'm making predictions over a grid. So I'm getting specified cell center, cell size, and cell dimensions for my grid. And then I'm saving it. Now, after I write it, I can also read it so that down the road, if I need to get the object, I can just, save it, grab it later. And here's the detailed information about what's going on. Now here, we're going to be working with soil this time instead of zinc. So here we have values of 1, 2, or 3 for the soil. We see the frequency there. Now this step, this says instead of 1, 2, and 3, I want 0, 1, 2, just shifting one to the left. Here are our category names. I'm going to go ahead and save my soil data set as a TIFF. And here I am taking the GDAL info and storing that as an object here. And you'll notice that I can, once I do that, I can grab anything from the object that I might want. All right, so soil TIFF is a GDAL driver, GTIFF object. It has 104 rows, 78 columns. Here's a warning about its projection. And now here, I've got everything converted to the format of the category names instead of factors. It's a little bit more informative. Now here, this function, the GDAL drivers in the RGDAL package, tells me which drivers I've got to work with and some information. Now, something that will come up quite a bit is that we will have XML files that we need to read. All right, so to read this, which is originally from OpenStreetMap, but the main point of this part is that this is an XML file. And when I want to read that in, you'll notice that I can use read gdal to get that into the system. Now, this didn't work out on my machine. Now the code conceptually works. It's exactly what we want to do, but it didn't work on my machine. So what I'm doing here is I'm just taking the author's code and the author's data set and running it. Originally, the author used this to get the XML file into R. Now, another thing we'll want to be able to do is to get an OpenStreetMap file into R, into our system. And once again, I'm going to use read gdal for that. Not a surprise there. I'll get a summary. And so here, I get information about the bounding box on the coordinates. It's a spatial grid data frame. Here are the data attributes for each location. And so here, that's 0 to 255. That looks like maybe colors to me. 256 is 2 to the power of 8. So 256 and that 0 means there's 256 range of each of them. And let's go ahead and get an image. And so now I can see the map very nicely. Thank you, OpenStreetMap. All right, now another thing we can do is read in Google Maps data. And now, of course, we could use ggmap to do this, but here I'm trying to focus on the SP package based, things that are more fundamental to R. So we're going to use the SP package to do this. So originally, the author got this map from using our Google Maps. ggmap would also be a good tool to use. Either way, it works out. And they loaded it in, now, and then they saved it. What I'm going to do, I'm just going to load in the author's save. All right, now I'm going to do a do call. So I'm going to do row binds on each of the items in the bounding box. And now here, the difference is I'm subtracting consecutive values, and then I'm reversing that, and I'm going to call that the difference in the bounding box. And here I want the dimension of cells, and I want cell size. So that's the difference between the difference between sides of the bounding box divided by cell dimensions. I need to know my offsets. So here I'm just figuring out the middle point for each cell. And now I'm going to specify my grid topology. My grid topology, I need to specify my cell center offsets. I need to specify how big my cells are, and I need to specify the number of cells. So I have the number of cells, how big the cells are, and where is the center of each cell. Need to specify my projection. As always, we do that over and over and over. And now I want to actually slap down my spatial grid data frame with my topology, my grid topology, that is, not mathematical topology. And then I specify my projection, and then I specify what my colors are. And let's take a look. I'm like, oh, hey. Now, this isn't a very useful map, but I can at least see what's going on. All right, so OSMAR is OpenStreetMap access for R. And so the author used an OpenStreetMap API to get a particular map. Here's the map, the bounding box that the author used. And this is in the Torget neighborhood. So now let's go ahead and load that data. Now what we're doing here is I'm taking the target data and I'm saying, hey, these are lines. These are not spatial points. These are not polygons. These are lines. And so now let's take a look at what we've got. All right, so we can see that this one is the most frequent, while this one is the least frequent in my table. Now, something I might want to do is look at the ones that are tagged as light rail. And here I'm using the find function in OpenStreetMap access to R, specify which target I'm looking at. And then here is the tag. And here is the way for the condition for it. And we can repeat this several times to get things specified down to something a little bit more precise. So here, this is for find. This is for find down. Now here you'll notice I'm using IDs. Up here, I specify the condition. Here, I specify the ID I'm looking for. Here, we're subsetting the data to only what I want. And then I'm converting to a spatial lines. So let's bring it all together. Let's go ahead and take that map that we got, the neighborhood, and the lines, and plot it all together. I'm using image for the base. It's all about that base, Then I'm plotting. You notice I have add equals true. And then I plot again, add equals true. And boom, we can see that this is what we've got. So here's my base. Is most of the color is the base. I can see, so that's coming from image, that's SG my map. Target 1 gives me most of these lines. And then this thick orange line is for bybane. That little part right there. And I can also plot this using my map as a raster image. And now I can sit here. What we're going to do, we're going to save that fires data set that we looked at previously when we looked at fires in Europe and specifically Greece. I want to save that using write OGR. I'm specifying what it is I'm saving, data source name, the layer I want it to be. Here's the driver I'm using, KML. And I'm saying, hey, go ahead. If it's already there, go ahead and overwrite it. If this is equal to false and it's already there, then I'm going to get an error thrown. Now, what we're going to do, we're going to take the MeUseGrid, and I'm going to say, hey, I want this to be converted over to a spatial polygon. I'm going to specify that that spatial polygon's projection be the same projection as the MeUse data frame. Now here, I'm using the map tools function to union the spatial polygons together. So I want two separate polygon sets, put them together into one big polygon set. And that's what this function is doing for us here. Now this step is I'm transforming everything to have that WGS84 projection. Now, on this step, what I'm doing is I'm taking the spatial grid data frame. I'm saying this object specifies my grid. This object specifies my projection. And this object specifies the data in spatial grid data frame. And I'm converting this over to a spatial pixel data frame. And now, get the projection I want, be consistent with everything else. And now I'm going to do an inverse distance weight model. And I'm going to go ahead and save and make an image. Oh, it did. Here's my image, but it did not post in our Markdown. Darn it, I wanted to show it to you. It did save though. And here's my KML overlay, just so I can see what's going on. And this next source, what's going on here is the author had some code that was distinctly separate from the rest of the code. It's kind of like in a sub file, and the author runs it, and we get some box plots. I believe this is cholera data, cholera cases, and location to wells. All right, well, that's all I've got for you. Take care and goodbye.